After Pro.
Hi guys, for this video I am going to discuss the parallel connections of resistor, specifically equal resistors in parallel. And for my next video, I am going to discuss the unequal resistor in parallel. Parallel connection of resistors can be like this, but also it can be like this. Just remember guys that parallel connection is connected in such a way that all the other ends of the resistor are connected to one of the side of the source, while the other ends of the resistor are connected to the other side of the source, just like the image show. For a number of equal resistors connected in parallel and connected to a source E in volts, and each of the resistor have the ohmic value of R ohms, which have the following conditions which I am going to discuss. Okay, for the number 1 guys is that the voltage across each of the resistors are all equal to the voltage source E. Then the number 2 condition guys is that the individual resistor current are equal, and each current is equal to I of R is equal to E divided by R. Then the number 3 condition is the total current. I total is equal to N multiplied by E divided by R, or N multiplied by I of R. Meaning that if you have the number of resistors in parallel, you just have to solve the IR, which is E divided by R, where E is the total voltage and R is the ohmic value of each resistor, and will be multiplied by the number of resistor. The next condition guys, which is number 4, the total equivalent resistance of the circuit, R total is equal to E divided by I of t, or E divided by N multiplied by E divided by R, or simply R divided by N. For R sub t, which is equal to E divided by I sub t, R sub t is the total equivalent resistance, E is the voltage source, and I sub t is equal to the total current flowing in that circuit. Guys, the second formula for R sub t, which is E divided by N multiplied by E divided by R, is derived from the first formula, which is E divided by I sub t, where I sub t is equal to N multiplied by E divided by R. Or simply guys, for the third formula, R divided by the total number of resistor. And then for the number 5 condition is that the power taken by each resistor, P of R is equal to E multiplied by I of R, where E is the voltage and I of R is the current flowing in each resistor. Or it can also be solved by P of R, which is equal to E multiplied by I sub t divided by N, where I sub t is the total current flowing in the circuit, and the N is the total number of resistor. Another way guys to solve P of R is that I of R squared multiplied by R, where I of R is the current flowing in each resistor, and the R is the ohmic value of each resistor in parallel. And for the last formula, I sub t divided by N squared multiplied by R, which is the total current divided by the number of resistor squared multiplied by the resistance. So we go now to the example. 4 equal resistors are connected in parallel with ohmic value of 40 ohms and connected to a 120 volt source. Find I of R, I of t, R of t, P of R, and P of t. So for I of R, we are going to divide voltage source to one of the resistor. Okay, the solution for number 1, I of R is which is equal to 120 volts divided by 40 ohms. So the answer guys is I of R is equal to 3 amperes. So the current flowing in each resistor will be 3 amperes. So for number 2, I sub t, which is the I total, can be solved by I sub t equal to N multiplied by E divided by R, or I sub t is equal to N multiplied by I of R. Since I of R is equal to 3 amperes, so we will have I total is equal to 4 multiplied by 3. So the answer is I total is equal to 12 amperes. Next would be Rs of t, which can be solved by E divided by Is of t, or E divided by N multiplied by E divided by R, or simply R divided by N. Since I total is equal to 12 amperes, then R total is equal to E divided by Is of t. So the solution, guys, is R total is equal to 120 volts divided by 12 amperes, which result into 10 ohms. Or it can also be solved by E divided by N multiplied by E divided by R. And the solution is 120 divided by 4 times 120 all over 40, which is equal to 10 ohms. Or simply R divided by N, which have the solution R total is equal to 40 ohms divided by 4, which result also into 10 ohms. Another, guys, is piece of R and piece of T. Since piece of R is equal to E multiplied by Is of R, we will have piece of R which is equal to 120 multiplied by 3. So piece of R is equal to 360 watts. And for piece of T is simply multiply 4 by piece of R. So the solution, guys, is 4 times 360, which result into 1440 watts or 1.44 kilowatts. So as a summary, guys, the conditions in solving parallel connected resistors are: number 1, the same voltage E is impressed across all resistors. For number 2, the individual resistor currents are equal, and each current Is of R is equal to E divided by R. And for number 3, the total current Is of T is equal to N multiplied by E divided by R, or N multiplied by Is of R. Then number 4, the total equivalent resistance of the circuit can be solved by Rs of T is equal to E divided by Is of T, or E divided by N multiplied by E divided by R, or simply R divided by N. And lastly, number 5, the power taken by each resistor, piece of R, is equal to E multiplied by Is of R, or E multiplied by Is of T divided by N, or also it can be I squared multiplied by R. And lastly, piece of R can be solved by Is of T divided by N squared times R.
Hey guys, thank you for watching. See you on my next vlog. Please don't forget to like, share, and subscribe for more videos.